This question is asking us, or is telling us, that the point A, which is 3, 4, lies on a straight line which has a slope of -2. And they're asking us to find the equation of the line. So first, let's highlight the information that they've given us in this question. They say that the point A lies on a straight line and the slope is equal to -2. Now we know that any given linear equation, the slope intercept form of the linear equation is y is equal to mx plus c. And we know that y is equal to -2x plus c. They've given us the slope, which is -2. M is the slope. Now we don't know c, but what we do know is that the point A lies on this line. So if I plug in the values for the point A, right here, if I plug it in, y is equal to 4 when x is equal to 3. So -2 times 3 for x plus c, and then c is equal to 10. So my linear equation is y is equal to -2x plus 10. So that's one way of solving for this question. Now, there's another way in which we can represent the linear equation. We've already learned the slope intercept form. In the slope intercept form, the linear equation is always written as y is equal to mx plus c, where m is the coefficient of x, m represents the slope, and plus c tells us the y-intercept, as in the value of y at which this graph would intersect the y-axis when x is equal to 0. Now let's look at a line over here. Now if we have any line, if we have a line over here, let's say we have this line over here. Now if we look at this line, let's say I've been given a known point, and let's call that known point x1, y1. I know that if I move from x1, y1 to some other point, let's say x, y, some other point x, y, my change in y over my change in x would be equal to my slope. My change in y over my change in x would be equal to the slope. So if I go from y1 to y, my change in y is simply the difference, right? So my change in y is m is equal to y minus y1 over x minus x1. Now, so that means if I take x minus x1 on the other side, if I multiply both sides by x minus x1 to get rid of this fraction on the right hand side, I get m is equal to, or m times x minus x1 is equal to y minus y1. So y minus y1 is equal to m times x minus x1. Now this over here is called the point slope form. Now what do I mean by the point slope form? Well, if I have any given point on this line and the slope of the line, I can find the equation of this line. So let's apply this point slope form. To find the linear equation. So the x and y remain as it is, but the known values are x1 and y1. So let's take a, and let's say that a over here is x1, y1. This is x1, y1. So then y minus y1, which is 4, y1 is equal to 4, right? That's the y value of a, is equal to m, which is -2, times x minus 3. So then over here, if I rearrange it, I get y minus 4 is equal to -2x plus 6. And then that implies that y is equal to -2x plus 10. So I get the same linear equation. So over here, this form of the linear equation, as we've already learned, is called the slope intercept form. So if I look at this linear equation, I realize that the slope as well as the y-intercept are very clearly visible when y is the subject on the left-hand side and x is the object over here. So x is multiplied by the slope plus the y-intercept. Whereas over here, this is the point slope form. So this form of the linear equation, this is the same linear equation over here, This is the same linear equation over here, but instead of representing it as a slope-intercept form, this is written as the point-slope form. So the slope is very visible, and just by looking at this, I can tell that 3, 4 is a point on this line with slope minus 2. So there's two ways of representing a linear equation. One way of representing a linear equation clearly shows me the coordinates of one point on this graph and the slope, which is the point-slope form, where the slope-intercept form clearly shows me the slope of the graph and the value of the y-intercept.